So Elixir is a dynamically typed language, but it comes with type specs, and they don't seem to be in very many tutorials. What's the deal with that? Hey, what's up? It's Mark at alchemist.camp, where we learn Elixir and Phoenix by building things. I have recorded over 200 Elixir tutorials, most of them free on this YouTube channel, and very few of them have type specs. So you might be wondering, is this because I hate type specs? No, not at all. However, there are some reasons they haven't been in earlier tutorials. Main thing is it's a cross-cutting thing. I could write type specs in tutorials on anything, and it'll take up time, it'll take up space, so I either need to show less code in the screen and scroll more, or I need to zoom out further, both of which have a cost. So we're just going to do one video on type specs and types and using the tooling that we get, and you can see how it all works. First, speaking of tooling, let's check out the Elixir LS. If you use Visual Studio Code, you can use this plugin. If you're using something else, you can still use the Elixir LS, or you can just use Dialyzer and take advantage of types. One great thing about this is we have it all integrated into our environment for us. So while we're writing type specs, or even while we're writing other functions, we can get warnings based on things that clash. So let's have a look at this rational module I've written here. This is fairly basic module for rational numbers. If you've forgotten what those are, that's a number that can be expressed as one integer divided by another integer. So 2/3 is rational, 3/5 is rational, the number 6 is rational, the square root of 2 is not rational, pi is not rational. This module does a bunch of stuff, so I'm going to give you a quick tour of some things in it, and then we'll look at how to type it. Okay, probably the simplest thing in the module is the factor function. So rational.factors of 52 is 2, 2, and 13. So that just broke 52 down to its prime factors. 2 times 2 times 13 is 52. And it gets used under the covers. So we can make rational numbers with the new function. So 2/9, it would be a rational number. Rational.new 2 and 9. And you can see under the covers it's storing 9 as a list of 2 3s, because those are the prime factors of 9. And similarly, if we made another one for 3/5, it'll do the reduction for us. Say we said rational.new 30/50. Well, that's the same thing as 3/5, and it'll reduce it for us. And we can print them out. Actually better not set it to equal. We can just do rational.print 3/5. We get a more user-friendly display there. And there are other things in here too, like multiplication. So rational dot times 2/9 and 3. Well, that's going to be 2/3. And we can also multiply one rational by another. So 2/9 times 3/5 is 2/15. So there are a lot of different ways to call these functions, which makes typing it a little bit more of a challenge than would otherwise be the case. So let's dig in here. In order to type something, we use a spec. So this is a module attribute. It has no effect on how the code runs. Module attributes are generally used either as constants or used by tooling. In this case, it's used by the tooling. So spec for factors. Now what we do is it's like we're defining the function, and then inside we use the types instead of the argument. So n has got to be an integer here. So integer, and there's a type spec function called integer. Now functions without the parentheses, well, that's actually still the same meaning, but the Elixir formatter is just going to add these in anyway, so we might as well do that. And then a double colon, and then the return type. The return type is going to be a list. Now, we could just leave it as is, leave it as a list, or if we want to be more specific, we can say list of integer, and this will only be valid if everything inside that list that gets returned is an integer. Now, this function is a pretty straightforward loop using a tail recursion and an accumulator. If you're not sure how this kind of function is written, you should check out my video called Looping in Elixir. The whole thing is about this kind of tail recursion with accumulators. So our workhorse that factors kick it off to is called factor. It has a numerator, it has a denominator, and it has an accumulator. And when we call factor, we've got some integer n as the numerator, the denominator is 2, and the accumulator is just an empty list. As we go through and process it, this second number will go up to higher and higher prime numbers that we're checking, and this accumulator will fill up with the factors that it actually has. So this spec is going to be factor, integer, another integer, and then a list of integers, which is what the accumulator's got to be. And we get a squiggly here because there's no return. We'll have to return a list of integers. Okay, now with that done, let's take a look at the opposite. There's a defactor function that takes a list of numbers and then reduces them into one number by multiplying them all together. It literally just undoes the factor function. Spec here will be defactor and numList, although one good thing about writing type specs here is it's made me think about it more clearly than I was making the module to begin with. It's actually going to be a list of integers, not numbers. So integer, and it's going to return a single integer. Okay, then let's look at divide. Actually, let's look at the main module first. We're going to do this in a few steps. We're going to make a new type for rational. It's just going to simplify things if we have a single type we can refer to as rational instead of this more complex struct. So to do that, we'll use a module attribute called type, and then we'll name the type. I'm going to call this rational, and this is essentially like a function declaration. So it's got to be lowercase. We can't use under module or rational itself. And it's going to return a rational. So here we could say rational, or we could say under module, which will just be whatever the name of this module is. So we could change it to fraction and then wouldn't have to update this here. And just like we could do with a list by putting the type used inside the list in something that looks like a list, we can do the same thing with a struct or a map, either one. So you see here we have struct, and it's got one item p, and p is an integer, and q is an integer, or are they? Well, we'll see very soon. So save that, and we'll go down to handle negative. Handle negative is just something to make sure if there's a negative sign, ends up on the numerator. So for example, if you have negative 1/3, that's fine. But if you have 1 negative third, that'll get changed into negative 1/3. So make a spec here, spec handle negative. This takes a rational, and it also returns a rational. And all is good. Or is it? What's wrong here in the new? Okay, we haven't written the new function yet. New is going to be a little bit more complicated because we have multiple options here. So when we define this function, we can just call it with 2 integers, or we can call it with the factors we're going to use to create the rational. So we could do rational.new. When we did 2/9, we did this. We could have also done 2 and then a list of 3 and 3. Reason for that is it just makes it easier to create new rational numbers. That's really convenient when we're doing division. So up here we multiplied 2/5 by, or 2/9 by 3/5. If we divided it, well, dividing two fractions, you're basically multiplying the first one by the reciprocal of the second, and it's really useful to be able to just pass in these lists of factors instead. So this is 10/27. What we need to do here is we need to let it take a rational, or no, we need to let it take an integer or a list of integers as the first argument, and then the same thing for the second argument. So integer or a list of integer. And if we wanted to, like if we had this all over the place, we could have like another type we could call int or list and define it as this, but there's no real need for that here. So we have an error because we're not returning anything. This is definitely going to return a rational. That's the one job of the new function. Okay, our squigglies are gone, except for handle negative. It will not succeed. What's wrong here? Well, it'll be clear in a moment. Let's go on to divide and times. So for divide, we've got a function that can take a rational and then either a rational or an integer. And then it returns a rational every time. Save that. And we have an error, even though this is definitely right. A divide will take a rational as the first argument every time. Then the second argument could be rational or it could be an integer. So what's wrong here? Well, if we hover it, we get some help from the dialyzer, which is one of the big benefits of specs. So it looks like our problem is we have specified something where P and Q can be lists of anything, but they should be lists of integers or integers. Problem is we had the wrong definition of our rational. Rationals should have an integer or a list of integer. So integer or list of integer, and Q should also be integer or list of integer. In fact, that's not right either. The actual rational struct itself is always going to be reduced to a list of integers for both of those. So we save that. Now the squigglies are gone, and we can go on and create a very similar spec for times, which is going to take a rational and return a rational or an integer. Then the only ones we have left are plus, which is, let's see, is plus any different? We have a rational and an integer, or a rational and another rational. So plus is the same deal. And then finally we have print and toString. String is the more straightforward of them, so we'll do that. ToString is going to be a function where the argument is a rational and the return is going to be a string. The type function for string is string.t, which is actually typespec.t. Save that, and now we have everything except the print. Print isn't really supposed to return anything. We've just got that for printing, so we might want to make it rational and none or no return or something like that, but it's not really what either are intended for. No return is for when you've got something that just throws an exception or loops forever. What we can do is we can just give it the same types that io.puts has, and that would be string dot chars dot t, or just an OK. And with that, we've got pretty much the whole module typed, which means we get helpful warning squigglies when we're making a mistake, and just a bit more safety as we go forward, either using these functions externally or adding to the module. One last thing I want to point out is, just like this string.t type, it's very common if you make your own struct or your own protocol to name the type for the thing itself t internally, and then externally everything can refer to it as whatever that struct is .t. So if we do this, now externally anything that wants to use the rational module can just say spec my function is going to take rational.t, and it's going to return a rational.t, like so. Just makes things a little bit more ergonomic. No one has to guess what the name of the struct is. You can't actually have a module be its own type. So the convention is you just make a function on it called t, and that is that. Hope you found this useful. I'll see you next time.